friends, our today's topic is bridge rectifier. Now in previous module we covered half wave rectifier where we used one diode, then the full wave rectifier where we use the two diode. Now here it is a bridge rectifier. So in bridge rectifier we are using the 4 diode. Now here we apply input in between the point A and B, and we are taking the output in between the point C and D, and here the load is connected in between the point C and D. Now this diode, it is connected in such a fashion that at any cycle out of 4, 2 diode is conducting. So this is the construction of bridge rectifier. Now how it works. So when we apply the positive cycle, so this is the positive, this is the negative. So what will happen? Here this is the positive and this is the positive. So out of this, the diode D1, it is forward bias, as anode it gets the positive, while D2 it acts as a reverse bias because cathode of the D2 is get positive. So like this, because of this D2 is reverse bias condition. Next, now this is the negative sign. So this is the negative. That means cathode of D3 it will get the negative. Okay, and here for D4 anode of the D4 is it get the negative. So because of this what will happen? D3 it should be in forward bias condition. Now how the supplies flow? So for positive half cycle, positive A terminal, as my diode D1 it acts as a closed switch, and here D3 it acts as a closed switch. So how the path is complete? Positive A, D1, D, load C, D3, then B, and return back. So during positive half cycle, two diode conducting, that is nothing but D1 and D3, and across the load we will get the output voltage. Now during the negative cycle, so this negative point, nothing but here at A point it is a negative and at this B point it is a positive. So here because of the negative, what here D2 is now turned on because cathode get negative, and here D4 is turned on because here anode get the positive. So in negative cycle D2 and D4 is forward biasing, it acts as a closed switch. And now how the path is completed? So from this positive D4, D point through load C point, then D2, then A point, and then return back. So because of this what will happen? Here across the load we will get the output voltage in negative cycle also. And how many diode is conducting? 2 diode is conducting, that is nothing but D2 and D4. So see, this is my AC input waveform. Okay. So during positive cycle what we will get? We will get the output voltage. During negative cycle also we will get the output voltage, and cycle gets repeating. So in each cycle what we will get? The 2 diode conducting. Now what are the different characteristics of bridge rectifier? As we already covered what is mean by peak inverse voltage. So in this peak inverse voltage of the full wave rectifier, it is a Vm. Efficiency, as we know, efficiency is nothing but DC output power to the AC output power, and for the bridge rectifier the efficiency is 81.2%. So if we compare all the 3 types of the rectifier, that is full wave, half wave, full wave and bridge. So see, the number of diode used in half wave it is 1, 2, and here in bridge it is 4. Then VDC for half wave it is Vm by pi, 2 Vm by pi, 2 Vm by pi. Peak inverse voltage, it is a Vm. In full wave, because of it is a center tap, so we will get the Vm plus Vm 2 Vm. And this bridge configuration here, again we will get the peak inverse voltage as a Vm. Then ripple factor, Rectification efficiency. So see, if we observe the efficiency, it should be good, better than the half-wave rectifier. Transformer utilization factor, again in bridge it should be a better, and the form factor. So this is the comparison chart of all the type of rectifier. Thank you.